Hello, in this video, I will explain to you on how to solve this problem. Let's read the problem first. A hot air balloon rising straight up from a level field is tracked by a rangefinder 150 meters from the lift-off point. Okay, at the moment, the rangefinder's elevation angle is pi over 4. The angle is increasing at the rate of 0.14 radian per minute. How fast is the balloon rising at that moment? Okay, so here is the diagram of the problem here. The rangefinder is here, and we have the adjacent side is 150 meter. And here the height of the balloon is the opposite side of this right angle triangle. So this is adjacent and this is opposite. Remember that opposite divided by adjacent is tangent, right? So we have to use trigonometry right here. So we have trigonometry. Okay, we have the comparison between this opposite. So we will have y divided by 150. Opposite divided by adjacent is tangent, right? So I have tangent, and the angle here is theta. So I have theta like this, right? And then we can isolate for y. So we will have y is equal to 150 tangent of theta. Good. Okay. Now we know that we need to find out dy over dt, right? How fast is the balloon rising? So we take the derivative of this with respect to t. So we'll have the derivative with respect to t. Okay, let's see here. We have dy over dt. And then here we also have 150. And the derivative of tangent theta with respect to theta is secant square theta. But remember, we have to take the derivative with respect to t. So we need to multiply this by d theta over dt. Right? Okay. I think that is good. But we have some unconventional function here, which is secant square theta. But secant is just 1 over cosine, right? So we'll have dy over dt that will equal to 150 multiplied by 1 divided by cosine square of theta. And then this one will be multiplied by d theta over dt. And what we need to do is now to plug the numerical values, right? So we have to plug all the numerical values. Okay. We need to find out dy over dt when theta is pi over 4. So we have dy over dt when theta is pi over 4. Okay, that will equal to, okay, we will have 150 here divided by cosine squared of pi over 4. Okay, and then multiply that by d theta over dt. We know that d theta over dt is constant, so we'll have 0.14. So we'll have 0.14 here. Good. Pi over 4. That is not 45. Pi over 4, yeah. Good. So now we will have 150. And then pi over 4 is 45 degrees. And the cosine of it is 1/2 multiplied by square root of 2, right? So we have square. And then multiply this by 0.14. Good. And here, this one will be Okay, so we will have 150 divided by 1/2, right? So I have 1/2 and then multiplied by 0.14. Good. And 150 divided by 1/2 is the same as 150 multiplied by 2. So I'll have 300 multiplied by 0.14. And that will be, okay, 3 multiplied by 14 is 42, but these two zeros will cancel out the decimal, right? So we will have 42. 42. And what is the unit? Here we have dy over dt. And the unit of the height here is meter, right? So because this one is in meter, so we'll have this one is in meter. And what is the time? The time here is in minute. So we'll have meter per minute. And so the answer here, how fast is the balloon rising at that moment, is this one, dy over dt. When theta is pi over 4, that will be 42 meter per minute. And I think that's all for this problem. Hopefully I did not make any mistakes during my calculation. And as usual, thank you for watching. And if you get any questions, send me your problem to this email, rdsatria11@gmail.com. And thank you for watching and see you in the next video. Bye bye.